Hi everyone. In this lecture we will finish our consideration of the unit circle. So we just want to remember the definition of sine and cosine, plus what we know about some special triangles, the 30, 60, 90, and the 45, 45, 90. Given all that, we can construct the unit circle with these special angles built into them. And the following picture probably is the most important graph that you need to, not graph, but picture you need to memorize and understand and be able to recreate. So here it is, the unit circle. And you notice that if I were to draw this arc right here, that would create a 30, 60, 90 triangle. And remember that the values are square root of 3 over 2 and a half. For a 45, 45, 90, square root of 2 over 2. And this is a 60, 30 triangle, and you're going to get these values. We've already talked about how we get the values for those angles, sometimes called the quadrantal angles. What I would really like you to understand is that you really only have to memorize the values in the first quadrant. And if you understand those, then notice what you could do. If you start at pi over 6 and go straight across, yes, that angle is going to be 5 pi over 6. But do you see that the y values have to be the same because we've just traveled along a y line? The x values are going to have opposite signs because we've flipped over the y-axis. Similarly, if we were to take a value, say, right here and go straight down, well, that's a vertical line, or at least it should be a vertical line. And so what that means is that the x values will be the same, and the y values will be opposites. So once you understand this ability of going left and right, or up and down, all you need to know are the values in the first quadrant, and you can fill in the values in the second, third, and fourth quadrant with ease. One of the mnemonics that students sometimes use to remember the SIGM, the signs of sine and cosine, is known as this. All students take calculus. And here's what that means. These you can think of as being divided up into the quadrants. So here's quadrant, get it right, here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. And in quadrant 1, everything is positive. In quadrant 2, sine is positive. In quadrant 3, tan is positive. Tan is positive because both sine and cosine are negative, and so tan, which is the quotient of sine and cosine, will be positive. And finally, in the fourth quadrant, just cosine will be positive. Make sense? It's an easy little way to remember signs, SIGNs. So now that we have fully extended the definition of sine and cosine to all real numbers, the other trig functions the same, and we know how to read the unit circle, what we can conclude is that the domain of sine and cosine is all real numbers. And the range is just going to be minus 1 to 1. The biggest that the x value ever is 1. The smallest that the x value ever is minus 1. The biggest that the sine value is 1. And the smallest that the sine value is minus 1. So let me just try to write that down in a quick little table. So here's basically what we've said. For both sine and cosine, the domain is all real numbers. And again, for both sine and cosine, the range is going to be all values from minus 1 to 1, including minus 1 and 1. For the remaining 4 trig functions, we'll look at those a little bit later, but their domain and range will be different. And we'll learn more about the domain and range of all of the trig functions when we look at the graphs of the trig functions. And that'll be coming up in our next lecture. All right? So, just in closing, this picture, this unit circle, truly is the key to understanding trigonometry. And if you don't quite understand why these values are what they are, it's worth taking some time and trying to figure out exactly how it came to be. Remember how the 30-60-90 triangles look, the 45-45-90, and remember especially what the definition is for sine and cosine. Okay, that's it. See you later.